Today, we'll get into summary statistics. Measures of center include the mean, the median, and the mode. There are others like the mid-range and trimmed means, but in this class, we're going to use these three statistics to measure the center of a distribution. Given a sample of size n, the sample mean is defined as the sum of the n values divided by n. Many of you have probably not seen this summation notation before. What we have is the Greek capital sigma. This means sum. The bottom number is called the index. It tells us where to begin summing. The number on top is the upper bound. It tells us where to stop summing. So if I have something like I equals 3 to 6, 5 to the I, that would be you start at 3, you let the I start at 3 and go up to 6, and you sum everything. So it'd be 5 to the third, plus 5 to the fourth, plus 5 to the fifth, and then you stop at 5 to the sixth. So that's how that notation works. Whenever we use this notation, we'll be using it with subscripts like this. Here's an example of calculating the mean. N equals 4, so we add up the four numbers of the data and divide by 4. That will give us the sample mean. And we'll always put a bar over the variable to denote the sample mean. We'll always use n to denote the size of the sample. This is a standard notation that you'll see everywhere. The median is the middle of a set of numbers. To find it, rank the values in ascending order. If the sample size is odd, the median is the middle number. If the sample size is even, there is no middle number. So what you do is take the average of the two middle numbers, add them up, and divide by 2. And that's what you see in this example here. The set, we have n equals 4. The two middle numbers are 4 and 7. So the median is going to be 4 plus 7 divided by 2, which is 5.5. Both the mean and the median are thought of as being typical values for a set. If you randomly draw a single value from a set of numbers, you expect to get the mean. Sometimes the mean and median are equal or close enough that there's no meaningful difference between the two. But when they are far apart, when we have heavily skewed data, then we tend to choose the median to represent a typical value. If you look at this example, we have 10 employees of a company who all make the same amount. Then you have these two much higher paid employees who drag up the mean. Because of those two, the mean is much higher than the median. Those two salaries are so far from the others that we would refer to them as outliers. We say that the median is robust to extreme values like these because it's not affected by them to the same degree that the mean is. The mode is the least useful of the three. It's the element of a set that occurs the most often. When we're dealing with continuous data, there are so many options for the values to be that we don't see a lot of repeats. Some data sets don't even have a mode. In this course, the mode is mostly going to come up when we talk about the modality of a distribution, when we talk about its peaks, and we'll get into that with histograms.